Alright guys, welcome back to video 2 for D335, Introduction to Programming in Python. This is going to be covering chapter 34, question 2 or lab 2, so 34.2. If you haven't already, I highly recommend going back and watching the first video. Essentially I'm going to cover, in that video I cover a lot of the exam essentials, kind of like how it's laid out, and as well as how Zybook works, because you'll be taking your exam, your objective assessment, your OA in Zybook. So I recommend watching that first video. We'll cover it here again, but the majority of the explanation was in video 1, so just watch that. You can click the playlist, which will be down in the comments below. And as well, this video is going to have a couple more resources you can use in the description below. So without further ado, let's dive right in. This one is asking us to create a solution in Python that accepts an integer input representing any number of ounces. We want to output the converted total number of tons, pounds, and remaining ounces based on what the input ounces is. And it tells us very important information. There are 16 ounces in a pound and 2,000 pounds in a ton. The format of the solution should be like this. It's going to ask us to put a string or text value of tons, colon, space, white space, and then value 1 will be a variable, and then it does the next for ton, pounds, and ounces. So for example, if our program input, and again, if this is not familiar to you at all, go back and watch the first video. I explained kind of, what this is. So if our input is 32,035, which would be ounces, because it's taking ounces as input, then the output is this: 1 ton, 2 pounds, and ounces is 3. And so I don't have any of the comments marked in here just because the way I saved it, I removed them and I don't have a way to get them back. So normally your Zybook lab would have comments here, the hashtags, the pound symbols, or whatever you want to call them, comments with a little bit of information up here. And your exam, your objective assessment will have the same comments as well. Use those to your advantage. They give you basically the same information as up here, but it's easy to, instead of having to scroll up, you can just view them here. But in our case, we don't have them, but that doesn't really matter. It doesn't affect anything. So first thing we want to do is provide a way to give us a way to input something. We want to input an integer that represents ounces. So in other words, this means we want to create a variable ounces, and what we're going to store in that variable is whatever the user inputs, whatever they enter as an input. And again, it's going to be a data type of integer, so it's going to be our code will look something like this. We'll name our variable ounces, and this is going to be equal to an integer input. So again, it's int input, and again, in the first video, you want to have an extra parentheses, just remember, because you're defining input within the integer data type. So ounces equal integer input. A lot of people, that's one mistake they make. They just leave it like that with one closing parentheses, and they get it wrong. They have a syntax error. So just remember to close that off. It's little errors, but as you do more programming and hands-on training, you'll get used to it. So there we go. And so now we want to output the converted number of tons, pounds, and remaining ounces. So we have to do a little bit of math here. So let's backtrack a little bit and go over some basic stuff. This is something you want to become familiar with and understand, both for the practice exams as well as for the objective assessment, your actual exam. Again, your exam isn't going to be covering ounces and tons and pounds. It may be doing some other sort of measurement. It may be doing, like feet, yards and inches, or seconds, minutes, and hours. And so the important thing is to know how to convert. And again, we're gonna learn what's the modulo function, which is the parentheses icon in Python, and kind of what it does. Essentially, it is when you divide something, and the remainder of that is what your modulo is. So if you've taken the cryptography class, Introduction to Cryptography, I believe that's D334, you would have something like 15 mod 7. And that would mean you would have to figure out how many times 7 goes into 15 evenly and what your remainder is. Well, 7 times 2 is 14, which is as close as you can get to 15 without, going over. And so you have 7 times 2 is just 14 minus, subtract that from 15, you have 1. So 15 mod 7 is 15 divided by 7 and what your remainder is, which would be 1. So that's essentially the mod function. Long division, you learned it in school. I'll edit in a quick explanation on a whiteboard of how the mod function works. You're free to watch it if you need the help. If you understand it, just skip forward. I'll add a timestamp in the video. Alright guys, this is my third time recording this little segment because my file keeps getting corrupted for whatever reason. My audio's there, but the video cuts off halfway, so I'm not quite sure what it is. Anyways, I just wanted to give you all, in case you needed it, you can skip this part if you already know how this works. If not, I want to give you a visual graph or a visual representation of how the modulo or mod function works in Python and in general. You see up here on your screen 12 mod 5 or 12 modulo 5, 12 mod 5, same thing. If you've taken the introduction to cryptography class, you'll already be familiar with this. If not, what this is asking is it's just doing division. How many times will 5 go into 12 and what's the remainder, right? That's the modulo. What's the remainder? How many times will 5 go into 12 as much as possible with a remainder? So to do that, we just need to divide 12 by 5 or backwards. 5 times what number gets us to 12 or as close as possible. So 5 times 1 is equal to 5. We're not quite there at 12 yet, so we can go a little higher. 5 times 2 is equal to 10. We're not quite there, so 5 times 3 is 15. So that's too much. So we have to use 5 times 2. So 5 times 2 is 10. 12 minus 10 is equal to 2. So our modular remainder is 2. And so for this next question, 15 mod 7 or 15 modulo 7, same thing. How many times will 7 go into 15 as much as possible, and what is the remainder? It's a 0 if it goes in evenly. If not, then we'll have a different number. So 7 times 1 is 7. 7 times 2 is 14. We can go a little higher. 7 times 3 is 21. 21 is greater than 15, so we'll have to use 2. 7 times 2 is equal to 14. 15 minus 14 is equal to 1. So our answer is 1. Because 7 goes in there twice with a remainder of 1. The maximum number of times 5 can go into 12 is 2 times with a remainder of 2. For Python, for your actual code or a script, you'll be using the modulo function. And again, don't overthink it. It's very straightforward. It's asking you how many ounces will go into a ton and what is the remainder, what's left. So that's a very brief explanation of it. Again, if you need more help, honestly, you can just Google how modulo function works. It's pretty straightforward. If not, just drop a comment and I'll do my best to get back to you. But anyways, let's go back to that. Back to our code. So we have some important key pieces of information that we need to know. Again, normally you would have a comment that kind of tells you this, but I erased it, so we'll just go back to this. It's very important to know here there's 16 ounces in a pound and 2,000 pounds in a ton. In other words, we want to make a comment here. I recommend doing this just to keep track of it. Save your brain power for the actual programming it and not on memorizing conversions. So 1 pound is equal to 16 ounces. And 1 ton is equal to 2,000 pounds. Again, when you're doing multi-line comments, you can just do individual line, or you can just add 3 quotes, leave space, and input that here. Whatever works for you, we'll just keep it like this. So we have one more piece of conversion that's necessary. If 1 pound is 16 ounces and 1 ton is 2,000 pounds, then how many ounces is a ton? Well, we'll just multiply 16 by 2,000. And we get 1 ton is equal to 32,000 ounces, which is important. We're going to use that for our function here. So now that we have the number of ounces, the variable ounces, which will be provided by the user as an input, integer input, we can move on to the rest. And so we're going to calculate our tons first. And the reason why you want to go from your biggest measurement to your smallest measurement, because essentially you're figuring out how, if I have 32,000 ounces, how many tons is that? How many pounds is that? How many ounces is that? Using the remaining amount. So you're going to take 32,000 ounces, it's going to equal 1 ton. You don't use 32,035 again. You only use the remainder, the modulo, 35 ounces left. And so we'll move on that. So tons, we'll create a variable. It's going to be equal to an integer, because we're using an integer value here, up here. So we want an integer there. And so tons is equal to integer of ounces. And to calculate this, we'll just divide it by 32,000, right? Because the ton, 32 ounces equals a ton, so we'll divide by 32,000. So now we'll create another variable. You can name it pounds or whatever you want. Keep it congruent and flowing, in a way that we can understand. We'll name it remaining pounds, because that's how many pounds are remaining after we've taken that. So that's going to be integer data type again, and you're going to need 2 open parentheses, because we're putting parentheses within parentheses. And this is going to be ounces modulo, and we're going to go ahead and put 32,000 ounces, because that's how many ounces are in a ton, in parentheses, and we're going to divide that by 16. And for our remaining ounces, we'll create a variable, and that will as straightforward as ounces, whatever remains, modulo 16. So ounces divided by 16, and whatever the division on that is. And so that is our conversion tables. Again, if you were doing this with other measurements like inches and feet and yards, well, you would know 1 foot is equal to 12 inches, 3 feet is equal to 1 yard, and 1 yard is equal to 36 inches. So your numbers would be a little different, but you could write that up here. Or if you're calculating seconds, 60 seconds is equal to 1 minute, 60 minutes is equal to 1 hour. So how many seconds is 1 hour? Well, you just multiply the seconds by the minutes, 60 by 60, and you get 3,600. 3,600 seconds is equal to 1 hour. Your exam will have different data types, so I recommend just looking at it. It's not too hard to figure out, and you should be able to figure it out. Okay, so next thing we know, now that we have our formulas calculated, in our input, in our formulas, we want to go ahead and create our output. Again, this tells us what format it should be in: tons, colon, white space, and then your value 1, which is essentially what these are. This could just name it tons, remaining pounds, remaining ounces. And so, and this again is the format that it should be in. So the 1, 2, and 3 are actually what the variables are. And so you are going to print. And again, using F-string formatting. And again, if I sound off, it's 4:52 in the morning right now. I was awake editing the first video. I got about 3.5 or 4 hours of sleep. I'm awake, and so my brain is not fully functional. But I have to get these classes out because I submitted for graduation, and once they approve it, you no longer have access to the course material. So I need to get these recorded before I can no longer help people. So print, and you want to use F-string formatting if you recall from the first video. And we need the word tons, because it says it right here. That's not a variable, so we know it's a string. And so hit a white space for white space, and now we can use our variable in curly brackets, because that's the format. Whenever you're referencing a variable in F-string format, it'll go in curly brackets. And again, in the first video, when we referenced our variable, we had the formatting, if you remember. It looks something like this. That tells it the 2 decimal points. We don't need it for this, but if you did, that's where you would enter your decimal points. And then just closing quote and closing parentheses. Okay, so now the next thing we're going to do, and again, since pay attention to how this is laid out, it's tons on one line, pounds on one line, ounces on one line, right? They're each on their own line. A lot of people would add these all, and there's different ways of course, to program this. You can create a new line or however you want to. I recommend just the simplest way. Why overcomplicate it when it's something pretty straightforward? So go ahead and just create a new line of code, and we're going to do the same thing only this time we're doing it for pounds. And again, our variable is called remaining pounds. You can name it value 1, 2, or 3, whatever you want to name them. I think remaining pounds makes more sense because you can look at it at a glance and kind of know what you're looking at. That's one of the PEP 8 guidelines to use meaningful variable names. And so there's that. So now we'll go to our next line, which is going to be ounces. Again, string ounces, colon, space, and then you enter your variable, which is going to be remaining ounces. Okay. And now the last thing we need to do is go back and fix this because I had a typo. That would have given me a variable reference, a name error, because there's no variable that is named remaining ounces, or whatever it was. And so now that that's done, we want to always test our code, right? On the exam, you don't have a submit mode where you can submit your solution and it'll go through tests and see if they all fail or pass. But you will have a develop mode where you can enter input and you should get output. So again, always use the numbers provided. Use other numbers, of course. Don't just go with the one, but use the number provided, the input provided on the exam. Always use it because that's a guaranteed way to determine if your output will match the input. So take this number and enter it here. You can copy and paste it, or you can just manually type it in. And we're going to run the program. As you can see from our output, when our input is 32,035, our output should be this. Not only these values, but in this format. So we have tons, colon, space 1, pounds, colon, space 2, ounces, colon, space 3, right? Because 32,035 ounces is equal to 1 ton, right? That's 32,000. There's 16 ounces in a pound. So 2 pounds is 32 ounces. So subtract 32,000 and 32 from this number, and you have 3 ounces left. You're essentially just subtracting however many ounces go into tons, how many pounds can you get from the remaining ounces, and how many ounces are left, right? That makes sense, I think. And so that's where you're using your modulo function to calculate the remaining amount. And so you wouldn't use it for this first line because you're not getting the remainder of anything. It's however many fit into that, that's what you get. Then it's whatever's left over that you calculate. And so that works for this solution. Again, don't just check one input. This submit mode is available within the lab, but it won't be available in the test. But for example, just for the heck of it, we'll run it here. This is kind of going to demonstrate what I'll show in a minute. So again, when you enter this number, you get that. When you enter this, you only get 1 ton, right? Pounds and zeros. Pounds and ounces are 0 because 32,000 ounces is equal to exactly 1 ton, so you wouldn't have anything left. 15 ounces, you don't have enough ounces to make a ton, and you don't have enough ounces to make a pound because it's 16 ounces per pound, so all you have is the 15 ounces, and so forth. So for example, again, if I have 16 ounces, my input is 16 ounces, I'm going to have 0 pounds and 0 tons. I'm going to have 1 pound because it's going to round up to the next one. If I have, for example, 17 ounces, not only do I have enough for 1 pound, but I should have 1 ounce remaining, right? Or if I have 16 plus 16, which is 2 pounds, 16 ounces plus 16 ounces, remember a pound is 16 ounces, is 32. Should have 32. If 2,000 pounds, if I have 2,000 pounds, 32,000 ounces, 32,000 should give me just 1 ton. Again, a little bit of math here. It's not too complicated. If this number is confusing, I apologize. Just leave a comment and I'll try to explain it more. It should be pretty straightforward if you think about it. Essentially, you're just getting the remainder of whatever's left. It helps to visualize. Like if again, 16 ounces is equal to 1 pound, you'll have exactly enough for 1 pound. If you get 17 ounces, which is 16 of that is going to make 1 pound, you'll have 1 ounce left, so you'll have 1. Okay. Or likewise with 33. 32 ounces of that will go to 1 pound, and you'll have 1 ounce left. So you should have 2 and 1. Okay, so that one's that explained. It's pretty straightforward. Again, just break it down line by line. It helps to make yourself some notes. The exam won't give you every conversion or every bit of data in this format, but it'll give you enough to know how to calculate it. For example, 16 ounces in a pound. Yep, 1 pound is equal to 16 ounces, and 2,000 pounds is a ton. And so to figure out how many ounces go into a ton, just multiply the two values they do give you, right? So again, to figure out that third conversion, just multiply the two values they do give you. 16 times 2,000 is 32,000. So that's how many ounces, your smallest value, will go into your biggest value in tons. So for example, if we're trying to convert inches to yards to feet, we have 12 inches is equal to 1 foot. 3 feet is equal to 1 yard. So how many inches are equal to 1 yard, right? 12 inches equals 1 foot. 3 feet equal 1 yard. So 1 yard is how many inches? Well, we multiply the two numbers that we do have. 12 inches by 3 feet, 36 inches. There's 36 inches in a yard. Or if you're doing seconds, minutes, and hours, well, 60 seconds equals 1 minute. And 60 minutes equals 1 hour. So how many seconds are in 1 hour? Well, 60 times 60 is 3,600. So 3,600 seconds are equal to 1 hour. So again, pretty straightforward solution. If you know your conversions, it's actually one of the easier ones. And so hope this helps. Again, leave a comment or remarks or anything in the video below, in the comment box below, and I'll do my best to get back to you.